Hello everyone. We're gonna try to solve something like constant acceleration in each time interval. As you can see, you have a graph of v of t, and you have two segments. This is actually our first segment or time interval between 0 and 5 seconds, and the second segment between 5 and 15. If you look at the first segment, you see that the slope is constant, and as you know, the slope is actually acceleration, and we see that is constant here, but it's only for this segment or time interval. And if you look at the second segment or time interval, also slope is constant, negative but constant. Okay, so it also acceleration. Okay, also it is given that when t equals 0 seconds, the initial position of the object is 0 meters. Okay, let's go over the questions. Part 1, we need to find acceleration in each time interval. Then we have to draw the graph of a of t. Part 3, find vt in each time interval, which means it's a linear function for first time interval and second time interval. Then we're gonna find x of t in each time and interval, and also we're gonna draw the graph of x of t, and also we need to calculate the average velocity between initial time of 0 seconds and final time of 10 seconds. Okay, let's go to the solutions. Now, solutions for the first part. Let's go look at the first time interval. We know that definition of acceleration is delta v divided by delta t. We're going to use, of course, this coordinate and this coordinate, which means final velocity which is 10 meters per second, minus 0, okay, as you can see here, divided by final time of 5 minus 0. And eventually the acceleration of first time interval is 2 meters per second square. Now let's go over and see what is the acceleration of the second time interval, which is between 5 and 15 seconds. Let's go and see what we have. Okay, when time equals 15 seconds, we see that velocity is 0. Okay, here. And when the initial time of 5 seconds, the initial velocity is 10 meters per second, here. And finally, the acceleration of the second time interval equals to minus 1 meters per second square. Okay. Second part, we need to draw the graph of a of t. It will look like steps. Okay, this is the first segment or time interval, and this is the second time interval. We found that when we looked at the first time interval between 0 and 5, the acceleration was constant, and the value is 2 meters per second square. When we look at the second time interval between 5 and 15 seconds, we found or calculated that the acceleration is minus 1 meters per second square, and also constant for this segment. Okay, it looks like steps. Okay, this is the solution for part 2. Now we need to calculate or find the function of v of t for each interval. Okay, to answer this part, we're going to use this formula. Now, we know that when t equals 0 seconds, initial velocity is 0 meters per second, because let's look at the graph. It is given by the graph, okay? It is 0 meters per second, and we calculated in the previous part that acceleration of the first time interval is 2 meters per second square. Now let's substitute all those parameters with all those values, and we get when t equals 0 seconds, velocity is 0 meters per second, and of course the acceleration is 2 meters per second square. And this is the final expression for first time interval that describes the velocity. Okay, now let's go to the second part. Okay, when we look at the graph, we know that when time equals 5 seconds, we see that initial velocity is 10 meters per second. Okay, we can say that when time t0 for this time interval equals 5 seconds, the velocity is 10 meters per second, and of course we calculated previously, okay, that acceleration equals to minus meters per second square. And again, we're gonna substitute all those parameters with those values, okay, and we again say that when time equals 5 seconds, velocity is 10 meters per second, and acceleration is minus 1 meter per second square. And this is the final expression for velocity of the second time interval. Okay, next part. Find function of x of t in each time interval. Okay, we will begin with first part, of course, because we know this condition. Okay, of course we're going to use this formula for each time interval. We know that when t equals 0 seconds, the initial position is 0 meters, and from the graph of v of t, we already know that initial velocity is 0 meters per second, or we can actually use this function of v of t. When we substitute this parameter t with 0, we will get 0 meters per second, as you can see in this graph. So no mistakes. So no mistakes here. Okay, also what do we know? Of course, the acceleration in the first time interval, which is 2 meters per second square. Now we're gonna substitute all these parameters in this formula with these values. Okay, when t equals 0 seconds, okay, initial velocity is 0, and of course the initial position is 0, and this is our acceleration in the first segment. And finally we get this expression that describes the position of the object in first time interval. It's easy parabola. Now this parabola will be a happy parabola because the coefficient of this t squared is positive. Okay, let's go to the second part, to the second segment between 5 seconds and 15 seconds. Now you need to remember from the previous videos that final position, the final position of the first time interval when t equals 5 seconds, it is actually the initial position, okay, of the this is actually the initial position for the second time interval, which means the initial position for the second time interval, it is actually the final position, okay, of the first time interval. And we know the function t squared. Let's substitute t with 5 seconds. 5 squared equals 25 meters. This is our initial position of the object when we talk about second time interval. Okay, of course, we know that the initial velocity when t equals 5 seconds, which is 10 meters per second, you can go to the graph, okay, and to check it, and you will see that when t equals 5 seconds, the velocity is 10 meters per second, or you can just use this function, okay, and substitute t with 5 seconds, and you will see that the velocity is equals to 10 meters per second. Acceleration of the second time interval we calculated in previous part, which is -1 meters per second square. Now again, we're going to substitute all those parameters with those values. This one, and this one. Okay, which means that when time equals 5 seconds, the initial velocity is 10 meters per second, and of course the initial position is 25 meters, and of course acceleration is -1 divided by 2. Okay, if you open these brackets, okay, then the coefficient of the t squared will be -half, which means the parabola of this function would be unhappy, like this. Okay, the fifth part, probably we need to draw, okay, yes, we need to draw the graph of f of x of t, but before that, I need to calculate the final position when t equals 15 seconds, because I don't know what is going on after t equals 15 seconds, okay? So, to do so, we will use, of course, the expression for position of the second time interval, and we're going to substitute t with, of course, 15 seconds. You can check it by yourself and to see that actually the final position is 75 meters. And the graph will look something like this, okay? If you look at the first time interval, you see that parabola is actually happy, and when you look at the second time interval, the parabola is unhappy. Also, you need to see or to remember that when you talk about tangent, the tangent at this point, for example, okay, this tangent or instantaneous slope, it is actually, let's call it 10 seconds, okay, it is actually instantaneous velocity when t equals 10 seconds, which means the slope, instantaneous slope at this point would be, let me see, this is the, okay, would be 5 meters per second. 5 meters per second. This is the slope, instantaneous slope. Now, and if you look at final point in time, when t equals 15 seconds, the velocity, if you go to the graph or to the function, when you substitute t with 15 seconds, you will get the velocity 0 meters per second. Or you just go to the graph, because the graph is given. Okay, also you can see that the velocity is 0, which means if you go to the graph of f of x of t, then you need to understand that instantaneous or tangent should be 0. Okay, v when t equals 15 seconds equals 0 meters per second, which is the slope is 0 at this time exactly. And also, when you look at time of 0 seconds, the same. Okay, we know that initial velocity when t equals 0 also 0 meters per second at this time of 0 seconds. V equals 0 meters per second, which is actually the tangent of the slope. What else I wanted to note? Yes, of course, this point. When you go look on the graph of v of t and you don't see jumps, okay? We'll try to explain what is the point here. I mean, the velocity is what is the word? Continuously. Okay, I will give you another example. By if I'll try to draw this, let's assume. Sorry, too much here. Let's assume that I would draw something like this. Okay. And when I want to draw a slope at this point, then we have two slopes. Something that before 5 seconds, like 4, 9, 9, 9, 9, 9, then the slope would be something like this. Okay. However, and this is actually the velocity when time equals 4,999 seconds. But if you look at this slope here, let's say the point is 5.00000001 seconds, okay? Then it's something here and the slope is like this, okay? Bigger, okay? So if this is the situation that we have a smaller slope before, slightly before 5, and slighter after 5, the slope became bigger. Now, how we can see this situation when we go to the graph of V? Then we will get something like this. I'm sorry, just a second. We will get something like this. That the slope after a little bit after 5 will get, for example, I don't know, 17 meters per second. But it's not the issue. Okay, it's not the case. I'm sorry. Okay, we don't see this jump, so it means that the slope is slightly before and slightly after 5 seconds should be the same. You see that it's very smooth at this point. Okay, I hope you understood this point. Part 6. Find average velocity between initial time of 0 seconds and final time of 10 seconds. Okay, we have two methods to calculate this. Let's see. First method, we're going to use graph of xt or function of x of t. Okay, now if we want to calculate the initial position when initial time is 0 seconds, of course we're going to use this function, which is this function of first segment. We're going to substitute We're going to substitute this t with 0. 0 squared also 0. Where is it? Here. This is initial. This is initial position. Actually, it was given in this question. Okay. Now, final position 10 seconds. Of course, we need to substitute this time of 10 seconds in the second segment, which means in this function. Okay. We will substitute this with 10 seconds, also here with 10 seconds. And let's see which value we will get. It is equal to 62.5 meters. Now, finally, we can calculate the average velocity, which means delta x with displacement. Final position, 62.5 meters minus 0, it still remains 62.5, minus delta t, final time 10 minus 0, remains 10 seconds. And if you divide 62.5 by 10, okay, you will get that the solution is 6.25 meters per second, and this is our average velocity between initial time of 0 seconds and 10 seconds. Now let's see what is the second method. We're going to use an area under function of v of t. Okay, now the initial time of course is 0 and final time of course is 10. All this area is actually displacement, delta x. Okay, but this total area actually the sum of two smaller areas, delta x, this one, and the second one is trapezoid. This is triangular, okay, and this is trapezoid. Okay, let's try to calculate it. Also, I need this base. To calculate this base, okay, I need to substitute t of 10 seconds here in this function v of t. And we get that the velocity is 5 meters per second when t equals 10 seconds. Okay, finally we can calculate delta x1 and delta x2. Okay, let's calculate the delta x1. Base is 5, base, and height is 10, here, 10, divided by 2 equals 25 meters. Okay, now let's calculate the second area, which is area of trapezoid. First base is 5, this, okay. The second base is 10 times height, which is this value 5. We get this by subtraction 5 from 10. We have 5 here, and also divided by 2. Okay, and this is the value of, we should add meters. Okay, and now finally we can calculate the displacement between initial time of 0 second and 10 seconds. Okay, and we get that the final displacement equals 62.5, which is the same value that we got from the first method. Now, finally, we can calculate our average velocity, which will give us the same result. Now, sometimes professor or teacher can ask you, okay, show me this average velocity in the graph of v of t and x of t. Okay, it's not so hard. Okay, what you should do, this is initial point and this is final point. Okay, when t equals 10 seconds, the position is 62.5. Okay, this is the final coordinate, this one. And this is initial coordinate. What you need to do is just draw the straight line between those two coordinates, and this is how you show how average velocity will look like in this graph of x of t. Okay. Also, you will notice that this slope is constant, which is 62.5 divided by 10 will give you again 6.25 meters per second, which is again our average velocity. Now, how this average velocity will look like in the graph of v of t. This is the graph of v of t. Okay, it just will look like a straight line. Okay, between initial time of 0 seconds and of course 10 seconds. Now I need only to show you why it is okay. This is the average velocity equals 6.25 meters per second, and also you can check, and if you want to find the area, this area, all this area, okay, this is also will be 62.5 base times height. And also this is the same area that we calculated before, this area plus this area. Okay, I think we can stop at this point. Thank you very much. I will see you in the next videos.